Audio Jungle.
I welcome each and everyone for the next session of Shine Learning Fusion Center. We are concentrating about chemistry, that is Unit 7, Atoms and Molecule lesson. In that, we are going to see about moles concept in this lesson. To know about the mole, generally we denote any number of objects. We denote them in units such as 2 for pairs and 12 for dozens, right? So chemists decided to denote the number of atoms and molecules present in a bulk matter to be denoted in number of moles. So the unit to measure the atoms and molecules is known as mole. So what is mole? The definition of mole is going to be, mole is the amount of substance that contains, mole is going to be an amount of substance and it's going to contain what? Elementary entities like atoms, molecules and other particles, and it will be equal to the number of atoms present in 12 gram of carbon 12 isotope. So the stable one is what? 12 gram of carbon 12 isotope. We are going to take a mole as a unit to measure what? Atoms and molecules in a compound. So the definition is going to be, mole is the amount of substance and it contains what? These types of elementary particles like atoms. It may consist of atom, molecule or other particle inside it, and as there are atom in 12 present in 12 gram of carbon 12. So it is equal to what? Carbon 12, atoms present in 12 gram of carbon 12. So we need some number to measure it. So that number, the experimental number to measure this, the mole is given by Amedeo Avogadro. Amedeo Avogadro is an Italian scientist. So the exact number of atom present in 12 gram of carbon 12 is given by who? Amedeo Avogadro, and the number is going to be, Avogadro number is going to be 6.023 into 10 to the power of 23. So Avogadro number is what? 6.023 into 10 to the power of 23. This number is nothing but the number of atoms present in what? 12 gram of carbon 12 isotope. So the exact number of atoms present in 12 gram of carbon 12 isotope is 6.023. So then therefore the 1 mole is going to be equal to what? 6.023 into 10 to the power of 23, because 1 mole of a substance is equal to what? 12 gram of carbon 12. So 1 mole is going to be exactly equal to what? 6.023. It is nothing but the exact number of atoms present in this. So 1 mole is nothing but 1 mole is equal to 6.023 into 10 to the power of 23. This is known as mole concept. So next, why should we need to learn this mole concept? What is about mole concept? Mole concept is a study of collection of particles. What is it? It's going to be a study of collection of particles. Next we are going to study about mole concept. That is, why do we need to study about mole concept? What is the study of mole concept? The mole concept is a study of collections of particles by using mole, this mole as a counting unit. So we are going to use mole as a counting unit in order to express the mass and volume of the such unit particle present in a bulk matter. Unit particle that is present in a bulk matter. So mole concept is nothing but it's going to be a study of collections of particles. It may be atom, molecule or any other particle. By using mole as a counting unit, we are going to use mole as a counting unit in order to express what? The mass and volume of such unit particle present in a bulk matter. This is the use of mole concept. So for this only we are going to study this mole concept. Next, mole concept can be calculated in various means like number of moles of atoms, number of moles of molecule, number of moles of volume, number of moles of gas, and molar mass of gas, then number of moles of ion. In the number of moles of atom, the definition for mole of an atom is going to be 1 mole of an atom contains 6.023 into 10 to the power of 23. This is going to be an Avogadro number that is present in carbon 12 gram of carbon 12, right? So 1 mole of an atom definition goes like 1 mole of an atom contains what? 6.023 into 10 to the power of 23 entities, and it's equal to what? Gram atomic mass. Next, for mole of a molecule is going to be 1 mole of a matter. This is going to be 1 mole of an element, and for molecule it is going to be 1 mole of a matter containing 6.023 into 10 to the power of 23 molecules, and it is going to be equal to gram molecular mass. Here 1 atom, 1 mole of an atom going to contain 1 mole of an element, and it's equal to what? 6.023 into 10 to the power of 23 atoms, and it is going to be what? A gram atomic mass. Next, what? Molar gas. Here molar mass of gas is that 1 mole of any gas will occupy what? 22.4 liter at standard temperature and pressure, and it's known as molar volume of gas. So these are the various means by which moles can be calculated. So what is the concept of mole? Why should we study mole? Then what are the various calculation by moles? 1 mole of an atom, 1 mole of a molecule, and molar volume of gas. So these can be asked in 3 marks, and this definition can also be asked in 3 marks. So next we are going to see about percentage of composition. Still now we are so far we have seen all about. So next we are going to see about percentage of composition. Still now we have seen about the bulk matter, the atoms in a compound in a bulk matter. Now in this we are going to calculate the amount of a single atom present in the, that is the percentage of a mass of the atom present in a compound. So percentage of composition is nothing but it represents the mass of each atom present in 100 gram of compound. That is, we are going to calculate the mass percentage of each element present in the compound. So that is known as percentage of composition. So to calculate the mass percentage of an element which we need, we are going to do the calculation, that is the ratio between mass of the element present in the compound. So we are going to calculate the mass of an element which is present in the compound divided by total molar mass of the compound. So total mass of the compound divided by what? Mass of the element present in the compound. For example, if we take H2O, H2O is going to be a compound, right? So H is denoted as 2, that is hydrogen molecule is represented in 2, hydrogen is of 2 hydrogen is present, and oxygen is 1. So the mass of hydrogen is 1 and mass of oxygen is 16. Now we have what? 2 hydrogen, so 1 into 2 is equal to 2. Oxygen, we have only 1 oxygen, so 16 into 1 is equal to 16. So total mass of the compound is going to be what? 18. So total mass of the compound is going to be 18. Now we have to calculate the mass of hydrogen only. So now I am going to calculate the mass percentage of hydrogen present in my compound. So I am taking hydrogen molecule, that is the mass of hydrogen is 2. So I am going to put here 2 divided by what? My total mass is going to be 18. So into 100. So if I calculate this, I will get the answer like 11.11%. So this is going to be my mass percentage of hydrogen, mass percentage of what? Hydrogen present in my compound. So this is known as mass percentage. Percentage of composition is nothing but we are going to separate, that is we are going to separately study the mass of how much mass is percentage is represented for a single atom. So single atom, how much mass is occupied in a compound. So that is going to be by percentage of composition. So how to calculate this mass percentage of a single element is nothing but we are going to calculate the mass of the element present in a compound divided by the total mass. This is going to be a total mass of the compound. So this is going to be my mass of hydrogen only divided by total mass into 100. So my calculation will come, answer will come as 11.11%. This is known as mass percentage of hydrogen present in this compound H2O. So next we are going to see about Avogadro hypothesis. Avogadro derived the relation between what? Volume of gas and the molecules of gas molecule present in it in equal volume. So Avogadro law states that equal volume of all gases under the similar condition of temperature and pressure contains equal number of molecules. That is, equal volume of all gases under similar condition of temperature and pressure. Just imagine we are going to take different gases and we are going to give with them equal volume, and also we are going to give them with similar temperature and similar pressure. Now the Avogadro says that the equal volume of all gases under similar condition of temperature and pressure, the molecule will be also equal. That is, The molecule present inside it will be also equal in all these gases. So, equal volume of all gases under similar condition of temperature and pressure, they will contain what? Equal number of molecules. This is known as Avogadro's law, and it's experimentally, that is mathematically represented by V is directly proportional to N. That is, volume of the gas is directly proportional to what? Number of molecules. And it is then a constant is added. So V is equal to constant into N. That is, volume is equal to constant into number of molecules. How much volume is produced? It is equal to the number of molecules. This is known as Avogadro's law. Under what? Similar condition of temperature and pressure, and we should give what? Equal volume. So this is known as Avogadro law. Avogadro law is nothing but we should give equal volume of all gases under the similar condition of what? Temperature and pressure. They will contain equal number of molecules. This is known as Avogadro law. Next we are going into application, where and all will be Avogadro law will be applied. Applications of Avogadro law. The first is going to be, it explains Gay-Lussac's law. So first point is that it's going to explain what? Gay-Lussac's law. Next is that it can determine the atomicity of gas. So Avogadro hypothesis, that is Avogadro law, can determine the atomicity of the gases. Then it can derive the molecular formula of gas. Avogadro law can derive the molecular formula of gas. Mostly Avogadro law deals with gases only, volume of gases and the number of gas molecule. Next is that relation between the molecular mass and vapor density. It determines the relation between what? Molecular mass and vapor density. Next is that we can determine the gram molar volume of the gas at standard STP. So, application of Avogadro law, the first point is that it can explain the Gay-Lussac's law. Next is that Gay-Lussac's law. Next is that it can determine the atomicity of gas. Next is that molecular formula of gas. It can derive the molecular formula of gas. Next, the fourth point is that it can derive the relation between the molecular mass and vapor density. The last point is that the gram molecular mass of the gas can be found using Avogadro law at standard what? STP. These are the applications of Avogadro law. So, Avogadro law can be asked in 3 marks. Along with this, is Avogadro's law and the applications of Avogadro's law. Then we saw about mole of atom, mole of molecule, and molar volume of gas. So, in this session, we have completed these answers. These may be asked in 3 marks or even 5 marks. Next session with the second unit, that is unit 8, periodic classification of elements. Thank you, students.